This one's
Who goes here? Backing up. Dee, did you show up? Donna, did you show up? Emmanuel Gutierrez? Brenda or Jose? Colby?
Here.
Colby, I just had a sneaking suspicion that you were, I'm gonna keep checking my phone because I get texts from students.
And if you could just add multi-pin for Hugo, that'd be great.
I'm sorry, oh yes, a multi-pin, right?
Yes, please.
You got it. Okay, where was I?
I don't know why, but I was able to pin him.
You were? Good
Yeah,
one.
before. So maybe because I pinned him first.
Eric Mendez? Kevin Nolasco? That's not Kevin.
Here.
Kevin, there he is. Kevin, I see your jerseys mostly.
The-
Nolasco. D Rangel. D. John Sesser.
Here.
Michael Silva. Jose Nunez.
Here.
Aurelio Uribe. And Dennis Vega. Okay, Dennis Vega, Aurelio not here, Michael Silva not here. Those guys usually show up, so I bet they'll come in. D, Rafael? No. Eric Mendez? No. Jose and Brenda? Manuel Gutierrez? Manny? Donna Davis? Dario Alonso. Okay. So that's that. Couple things I wanna do. Let's see. Starting with you guys seeing my inbox?
No.
You're not? You guys aren't seeing my Gmail inbox?
Yeah. I am.
Yes, right?
Yes.
Good. Who said no?
It's John. No, I have something funny set up, so sometimes the screen shares pop.
You
something
seeing
else.
it now? Okay, so I wanted this to, let's see. Ah, criminy, where is this? Huh? So do you guys know about the CARES emergency grant?
No.
All right, so I'll read this with you. I'll read it and you can read along. Dear SBCC students, the recently passed federal stimulus bill includes funds for students to help with immediate needs related to the ongoing health crisis. Santa Barbara City College has been allocated approximately 2.9 million that will go directly to students in the form of CARES emergency grants beginning today. That was the 10th, so 3 days ago. We'll begin taking applications. So if you don't know about it, if you like, I can, Jim or Pat and I can forward this. As a matter of fact, I'm going to forward this to 59161, 59161, 2150. That's us. Okay. So I just forwarded that to you all of you students, and now you know about it. Okay. Now you all know about it. But, see anybody else show up? Dario, Donna, Manuel, Brenda, Jose, Eric, D'Angelo, Jose, Silva Nunez, yeah. No, you're already here. I got you here, Jose. Michael Silva, Aurelio and Dennis Vega? No, okay. I'll check again in a little bit, but so that's $2.9 million available for students. Don't let that money just sit there, man. Go after it. When we get done, check your email on your pipeline account and you'll have an email there and you could click on the form and do it. It's so amazing to me how streamlined some things, a lot of things have become, due to online forms. And online forms, well, for instance, I'm refinancing my house again because the rates have gotten even lower. And to refinance my house, I did it through like 2 phone calls and maybe, I don't know, no more than 20 minutes, maybe a half hour online, just clicking out a fill-inable form and then coming up with my Social Security letter saying how much I get, and my W-2 and a pay stub from City College, and I'm in. The loan. It was the easiest loan I've ever gotten in my life, bar none. And I owe it all to online infill forms and DocuSign. Okay, so we got Brenda and Jose. I see, I've shown. Brenda and Jose are here. Okay, since I checked last, I'll check again since Brenda and Jose showed up. Dario, you here? Donna? No Donna? No Dario? How about Eric Mendez? Eric, you're always here. How about D'Angelo? Michael Silva? Dennis Vega? Aurelio? Okay. Okay. So they're not here. So let's go right to, well, actually, let's go. I've in my notes here, just wanted to revisit this before we move on, and revisiting it because I learned something this morning. I learned that these 4 agreements that I talked about last week is what Tom Brady guides his life by. His favorite book, his favorite thing to read, his favorite life coach is the 4 agreements. Yeah, Tom Brady. I'm sure you all know who Tom Brady is. And if you don't, he's an unbelievable quarterback that pretty much won the Super Bowl, not single-handed, but 4 agreements again. 1, be impeccable with your word. 2, don't take anything personally. 3, don't make assumptions. And 4, always try and do your best. Now, just a note about that last one. I'm not going to expound on these things. It's a short book. You should get it. I think you'd like it.
Morning, Rodney.
Who's here?
Aurelio.
All right. Thank you. Thank you for checking in, Aurelio. How about Dennis Vega? Did you show up? Michael Silva? D'Angelo? Anybody that just showed up? Okay. So trying to do your best, that's going to change from basically minute to minute. My best right now may not be my best in 4 hours. My best in 4 hours may be different than my best this morning or tonight. It just depends on all kinds of factors. So best is relative to what you're doing at the time, and that's it. So next, CARES emergency grant. Really, that money's just sitting there. I don't want to say free money because you got to do the application and but I think being students, and I'm sure all of you are affected by COVID, I suspect that you're eligible, even though I don't know for sure, but I do know that the money's there. And that is pretty cool. Okay. All right. You seeing modules? Everybody seeing modules?
Yep.
Week 5,
Yes.
right? Question? No? No questions? All right, week 5, 213. I'll start out. I'll read a little bit and then I'll pick some people to read. This safety meeting topic, excuse me, is about asbestos safety. Safe handling. The idea behind safe handling of asbestos is to prevent dust from becoming airborne and being inhaled. Your company will have specific handling procedures based off of what type of asbestos material you are handling. In addition, some general safe handling tips are: inspect the area every day for asbestos levels. OSHA prohibits more than 0.1 fibers per cubic centimeter of air, which in parentheses is 0.01 F/cc, which is fibers per cubic centimeter, averaged over the 8-hour workday, and 1 fiber per cubic centimeter of air over a 30-minute work period. I can't tell you that I can explain too much of that. If you are unsure whether or not the material you're handling contains asbestos, treat it like it does. That's a good point. If you are taking asbestos material off the roof, seal it in a bag, pass it down instead of simply throwing it off the roof. Wear proper personal protective equipment. If you are working in concentrations of asbestos that are above the permitted level, wear coveralls, gloves, head coverings, respirators, and foot coverings. Do not bring your clothes home to be laundered. Restrict access to the area and set up warning signs that there is asbestos in the area. Clean up and disposal. Would you read that, Brenda? Brenda?
Asbestos waste should be wetted with water before you pack it up to keep the dust down. You must dispose of the asbestos material in leak-tight 6, I'm guessing, is that millimeter, plastic
mil.
bags. Okay, plastic bags, plastic-lined cardboard containers, or plastic-lined metal containers before it dries out. Clearly mark the bags containing asbestos.
Husband Jose, go for prohibited.
No matter what type of asbestos work you are involved in, when working with asbestos, you should never dry sweep with dust, smoke, eat, drink, apply cosmetics.
Okay,
And-
and the conclusion on this one? Catherine?
Asbestos safety procedures are extremely important. Am I on? Because asbestos is extremely dangerous. However, as long as you follow the correct safety procedures, you can protect yourself and your health when working with asbestos.
Okay, good. Now, we're gonna keep reading here, but before we do, well, I'll tell you after. So, how about Jesus Boreto?
Introduction. Asbestos is the general name given to the variety of 6 naturally occurring fibrous minerals. These minerals are resistant to chemicals, heat, and electricity, and therefore were widely used in all sorts of materials, from housing materials to shipbuilding materials. However, asbestos fibers are extremely dangerous to humans, so it's important to diligently follow the current asbestos safety procedures.
Thank you. Diligently, and it's heat, chemicals, heat, and electricity, or they're resistant to. Asbestos is resistant to chemicals, heat, and electricity. It's, you know, it was used as fire shield, still is in some places. Okay, hazards. How about you, Aurelio?
Hazards. Unbroken asbestos is harmless. However, when it is broken, dust is created and people inhale the fibers, causing extreme health hazards. For example, asbestosis.
Yes.
Asbestosis occurs when the asbestos fibers lodge into the lungs and create scar tissue. The scar tissue continues to develop until it completely covers the lungs, making it so that they can't work anymore. Mesothelioma. Mesothelioma is when there is a malignant tumor that develops in the thin lining of the lungs, chest, and abdomen. It is usually fatal. Lung cancer. Exposure to asbestos fiber can increase a person's risk of lung cancer up to 5 times. Additionally, if you're a smoker, you are 50 to 90 times more likely to get lung cancer than the average non-smoker who does not work with asbestos.
50 to 90 times.
Ugh.
Yeah. So I suspect that not many of you have a whole lot of experience working around asbestos. We pretty much limited, severely limited it in any new construction. As a matter of fact, if not completely gotten rid of it. Old transite pipe, which used to be the flue for the flue pipes for heaters and things like that, were made out of what's called transite pipe. And transite pipe, transite pipe was made out of solid asbestos. Now, I'm jumping around a little bit, but I want to tell you, the U.S. Consumer Product Safety Commission has a quote about asbestos. And I may paraphrase it, but I think it might be right on the money. And the quote is, if it's in good condition and non-friable, it's best to leave it alone. So that means if it's not flaking off or degrading and not friable, which means it's not, the fibers aren't able to get airborne. If it's like on your ceiling and it's in the popcorn insulation, which is usually sometimes 10% asbestolite, and it's in good condition and not falling off, it's best not to touch it and disturb it, because by disturbing it, that's when it busts up and the fibers get airborne, and it's a physical thing. This is not radiation that you're getting. This isn't, you are actually breathing in the fibers. That's how you get mesothelioma or asbestosis or any of the cancer caused by asbestos fibers. You have to breathe a lot of it over a period of time. So if you get a little bit of exposure, you're probably okay. You have to breathe a fair amount of fibers. So when you look at asbestos mitigation, guys that do it are licensed, and their workers wear Tyvek suits, dust respirators, well-sealed respirators. You don't have to bring in outside air, just so you they keep you from breathing in the actual fibers, and they use spray bottles and they wet everything down. Now, one tip I'll give everybody here, and that is, a lot of people don't like these blown insulation ceilings, like the popcorn on the ceilings, and a lot of that happened in the 60s and 70s, before we realized that asbestos was not a cool thing. And so you can, if you have a popcorn ceiling, if you have that blown insulation on your ceiling and wherever you live, and you're wondering if it has asbestos in it for whatever reason, you can scrape a little bit into a baggie and send it off to a lab. There's a couple of labs, and you usually get an answer back in a day, whether or not it has any asbestos in it. If it doesn't, you're golden. You can scrape it off, do whatever you want to with it. If it does, you either need to mitigate it with a licensed person that is licensed to mitigate, take the asbestos out, and then dispose of it properly, or you can do what we've done a lot of times, which is veneer it. So if the ceiling has got the insulation on it, you can we've put 1/2-inch drywall screwed to the joist through the existing ceiling, plaster, drywall with this insulation into the joist. So you have a thicker ceiling, but the asbestos is completely captured. It's usually considerably, significantly less expensive than asbestos mitigation, and it completely captures your asbestos. It doesn't get rid of it, but it definitely takes rid of the friability. Now, does anybody have any questions about that? No, none at all. Not one question. Okay.
Excuse me, Rodney, you said the word was friable, F-R-Y?
Friable, friable. And that means friable with the fibers get loose and can get airborne. When you break something up, it's friable. That answer your question?
Yes, thank you.
You bet.
I have a question, Rodney.
Fire
Catherine,
away.
was there a term when you cover up asbestos popcorn ceilings?
Well, we call it veneering it with 1/2-inch drywall, but just veneering it or capturing it, that's the term that I'm not sure that's a term you can find anywhere, but that's what I call it. We capture the asbestos by veneering the ceiling with new 1/2-inch drywall. It's a good way.
1/2 inch. Thank you.
You bet. So if you got an 8-foot ceiling, you'll now have a 7-foot, 11.5-inch ceiling, but you won't have to worry about that. Any asbestos fibers. Typically where you're going to see asbestos these days, besides a blown insulation ceiling, is you're going to see it in an asbestos paper wrapped metal duct for a forced air unit or a gravity fed unit for a heating under a house. You won't see it now, but you'll see it in an older house. Transite pipe, like I mentioned, which is a flue pipe for most furnaces that were done all the way up until the 70s, even 80s. And then you'll see it, they use asbestos fibers a lot in the mastic for vinyl tile. So a whole lot of linoleum or vinyl tile, a whole lot of tile went down in a whole lot of surfaces, I think mostly commercial, with mastic that had asbestos fibers in it. And if you pull up a tile and the mastic has asbestos fibers in it, you need to capture that right away or have it mitigated. So any other questions or comments about asbestos? And one good thing this thing said is that I thought was that if you're unsure whether the material you're handling contains asbestos, just pretend that it does. Treat it like it's dangerous. Err on the side of caution. And remember, non-friable. It's non-friable, you're safe, and try not to disturb it and make it friable. So let's go to our module, week 5. Well, you guys are in for a treat. You're in for a treat. I just happened to be doing some work up at the book building, and for those of you that don't know, Rodney out here. Well, you're in for a treat. For those of you that don't know what the book building is, I'll explain it kind of as I go, but it's on a 20-acre piece of property where the owner's house is the piano house, which is an amoeba-shaped concrete, glass, and steel house that I've rebuilt in this configuration after his wood house burned down in a T-fire. And simultaneously, and it took a couple of years to get the permit, we started building his museum, which is the book building. And let's just take a little tour of the book building. Normally, you'd have to get on a waiting list to get to a tour of the Hermitage, which is his whole grounds, which has incredible sculpture and incredible specimen landscaping. But that's suspended for COVID, but I happen to be the builder and doing a little bit of work there. So I took this opportunity to share this with you this morning. Today, we'll tour the book building. Here, doing a little bit of work, getting a guy lined out to do some work. I take this opportunity to do a little filming now. I'm not going to activate the exit loop, so I'm just going to show you a mailbox. I can't see it now. The mailbox is a big stack of books. Now, some of you may be familiar with this book building. You may have seen it up on Mountain Drive. But what's next door, which is also the same owner's property that I built the piano house for, is a mailbox that is a guy on a bicycle with his butt way up in the air, and you kind of pull down the backside of his pants to open up to access the mailbox. So you may have seen that. This is the book building. This is a museum. private museum. There's a story behind.
Can you turn the volume a little bit, Rodney? It's hard to hear you on the video.
Details of this. I wouldn't know in some ways. How's that?
Good.
Really where to begin. Let's I'll take you down to the carport and we'll go out that door. This is 10 books. Our benefactor has written every one of these titles, and the titles are the owner's the author of. The spines and the covers are copper. Pages are brass, 4 inches. There's a recess describing a page. I finished this job 9 years ago. Let's see, that one. Something around there. Our benefactor is a sculptor, or was. He's not sculpting right now. He's doing acrylic art, I think. Lots of outdoor sculptures on the property. The driveway is supposed to represent books. Imagine the problems here. At one of those Volkswagens holds one of the condensers for the AC zone, one of the zones of the two. These infill windows were beyond belief difficult in aluminum and glass. Carport, everything daylights. Out to here, there's a 1,500 gallon septic tank. Buried there are 2 dry wells that are 4 foot diameter and 50 foot deep. 50 foot deep, 4 foot diameter. Now try to picture that, a hole in the ground, not 1, but 2. 4 foot in diameter, 50 foot deep, 5 stories deep. It's like looking into hell, man. Filled with gravel to leach. And I had to build a road to get down here, get equipment down here initially, and then erase the road, and then start while we were doing excavation of the foundations. Anyway, here we go. So this is all storage over here. I'm not really gonna go in there. Just to know that this this basement is semi-subterranean. This is all copper under here. Going in this is the electrical panel. Templating these glass panels, compound miners, unbelievable. So this is the carport entry. It was laid out with 21 load points at the center of I-beams. This concrete column house I-beams, which you'll see as we go upstairs. This is the workers on the property's bathroom and break room and this utility room. Let's go up these stairs. It's an unbelievably complex fixed glass, plus it's super heavy. It was permitted as a residence, even though we knew it wasn't going to be a residence. So it had to have a kitchen, but the kitchen was pretty trick too. Like, you had to drain this kitchen up. Chase. A pretty interesting pantry. Very interesting pantry. Very well done too. So there are tours when we're not in COVID, I think monthly. So there's some snacks out, I think. And you can see the I-beams that support the structure. The skeleton is red iron, infill is steel studs. Had to have a bedroom. Had to have a bathroom. These books were custom tiles made. Nice window. The architect of this building is Bruce Wiesman Simmons, protege of Frank Gehry. Incredible architect. Oh my gosh, this is the foam core plan, his concept initially. Model, the owner really liked. I said plan, but I should have said model, foam core model. And decided to do. We're walking on 6 inches of poured concrete on a welded steel pan deck. I designed the staircase. Supposed to be all glass. This turned out to be too expensive. There's those 2 columns that you saw encased in concrete down below as we walked in. This is a museum for most of our benefactors. Most of this stuff is his, all the busts are, but a lot of it he's collected. This is his. That sculpture, all the big sculptures and the busts. I built this wall, which is hinged, so it stands up, and 2x6 steel studs. It slides along, so a place to hang art because there was a dearth of walls to be able to hang art in it. And a lot of art, sculptured by our benefactor. Well, office for the tours happen here. Books are sold, etc. Place for the guest book. More crazy infill. So crazy in this infill. Imagine glass tapering and nothing like that, and aluminum frame, aluminum and dual glazed glass. The mezzanine. Those glass treads are laminated. They're 2 1/4 thick, and they're rated to hold something like 2,500 pounds. That's the piano that burned from the house that our owner lives in. And he made a sculpture of what was left of it. This skylight bisects the building. And when I brought GNL here to do the skylight, they said, yeah, we can guarantee the skylight from water, but we won't build it. I said, why is that? They said, because both of these roofs shed onto the skylight, and it's just too much water. We can't keep water out. So we shifted design on the fly and built a built-in gutter on both of those spines that collect right there and right there, and plumb down through the walls, go all the way back to that part. And I said spines, I should have said covers. And take off and go underground, and then daylight out there. Love those metal windows. So let's take you out the entry for a second. See these entry doors, huh? That's just unbelievable entry doors. This is a cantilever slab. This thing is a real problem. In a bit, I'm sure the over excavation way back when to even start forming. I just had every problem that could possibly happen in a building based on the design of the building, really. If you can imagine, it was difficult, but so rewarding to see this thing done. Gosh. All right, let's go out. These doors, huh? You love these doors. I love these doors. Everything had to plane perfectly. The trim. No room for slop here, which is pretty incredible, really. Should do that. All right. Sort of de Bourgeois. This week used to be in the airport. It's only about 7,000 square feet. It's not gigantic. It's big, don't get me wrong. Utility room. Look at that, man. Conduit. Wiring. Oh my gosh, plumbing. Fire sprinklers? I think we're fire sprinklers. Yeah, we're fire sprinklers for sure. Fire sprinklers. Isonine. Open cell. Damn finger again. Pretty much throughout, pretty sure. Oh my gosh. CIP wall, it's cast in place wall. Just so many conduits, so many junction boxes, so many details. Line sets for the AC, the condenser. Yeah, I'd say that. Did I mention that the Ted or the owner wanted the condenser not to show, so he put it across the street. And I'll show you what he did. I think I might have mentioned that. So the other saw the one over on that side, the west side of the building, but on the east side, I didn't want to see it anywhere. So we wound up running the line sets under the driveway, and then we put the condenser in a Volkswagen. We put it on a pad and we cut out the Volkswagen and lowered the Volkswagen over it with its motor on top. This is all leftover tiles, mostly from the owner's residence, which is on another part of the property. Pretty cool. I would say so. And it's your CT111 instructor RDU over now. Well, what do you think, gang?
Pretty cool.
Not bad, huh?
Oh, that was awesome. I would like to go see that sometime.
So it's called the Hermitage. So if you go, let's see here. Review. Me on pin. Okay, here we go. It's called the Hermitage, Santa Barbara. Just like hermit and age at the end, all one word. Check it out. I'm sure they're not letting you sign up for tours. I'm positive they're not letting you sign up for tours now with COVID. But when things get to some sort of normalcy, they'll open it up again and there'll be sign up for tours. I think they take 16 people, I think once a month. And it starts in the book building and you talk about the book building. You get a little tour of the book building and then they take you out through around the main house, around the piano house, which has got some unbelievable stories as well. And then out through the grounds, which has specimen landscaping that's beyond belief. It has a cycad garden that is just, I don't know if any of you know about or have been to the Huntington Gardens in Pasadena. But as far as I'm concerned, it rivals them. And then also there is probably 400 sculptures on the property, and some the size of the computer, and some the size of a Volkswagen, and some the size of a small house. So it's really interesting. You get a chance. And from a builder standpoint, it was the most challenging between the piano house and the book building, most challenging jobs to date for me, and the greatest opportunities for me to learn, about this trade and learn how to do things I had no idea how to do, like shoring and things like that. And then like XYZ coordinates on the foundation. When I was doing this job, I was teaching, and so I had the plans, and I have a disc somewhere. At some point in succeeding classes, I'll probably revisit it. But just if I can describe this concept to you while you're watching me describe it. In most plans, you see a foundation plan has got lines drawn, and if the angles aren't 90, it's shown as not 90, and then the dimensions of the foundation walls and thicknesses, etc., are shown in feet and inches. Not so on this foundation plan. The foundation plan for the book building was laid out on an XYZ coordinate, which is what you would see in larger buildings, like multi-story buildings. And what an XYZ coordinate is that we have a datum point that we establish that goes through a certain part of the building. And then based on that, we have a surveyor survey right through that datum point, the X coordinate, which is due north and south. And then through that datum point, we have them survey the Y coordinate, which is due east and west. Now we have due east and west, due north-south coordinates, which are exactly 90-degree opposed, right? And the Z coordinate is a datum above sea level at a certain point in the building. And then everything is the Z coordinate, for height. For the Z coordinate for the carport would be one level, and the Z coordinate for the first deck could be another, and the mezzanine would show you how high those are. But in the foundation layout, the Z coordinate wasn't used much, but the XYZ, I'm going to try, I rarely try to explain this, and I know a lot of people don't get it, but it's all tied to the 3, 4, 5. So that's how this XY coordinate works. So if you have due north, south, X, and due east, west, Y, and you've got these load points, right? And the load points are centers of the I-beams that are the red iron structure or skeleton of the building. And let's say you've got an I-beam right here. In the center of that I-beam, based on these coordinates, it would say X 11 foot 9 5/8, Y 2 foot 3 1/4. So on the X coordinate, you would measure up on square, right? 11 foot 9 5/8, and run a string on a batter board and put a mark on your string, or an alligator clip we used with the strings.
Ronnie, I'm sorry, your back is to me. You're talking fast and I'm missing some words, so can you repeat that?
I doubt it, but I'll try. Okay, so 11 and 9 5/8 is the X coordinate. You'd measure up square, right? Dead square off of this line, square, you've already got a square point. So you measure square up from your point, 11, 9 5/8, put an alligator clip on it, and then we run another square line with a 3, 4, 5 triangle, 2, 3 3/4, and that gives a center line. And everything is square off this because the Y coordinate, it's not focusing, is it? It's bad focus. Come on. Damn it. Still kind of fuzzy, huh? Where do we have this? John, help us. Come on, man.
Cover the whole camera so we can't focus on. Oh, there you go.
We're there. All right, so everything is based on that 3, 4, 5 triangle. So, when you spread these strings out initially, you got a 3, 4, 5 triangle. So you could measure out here, 9 feet out. And you can measure out here, that's 3 times 3. And then 4, 4 times 4 is 16. You can measure out here 16 feet. And then you could move these strings until this point to this point, 16 feet on your string and 9 feet on your string, that this equals 25, because that's how the 3, 4, 5 triangle works, right? It's, 3 times 3, 4 times 4. You could use 3 feet, 4 feet, and 5 feet, or anything. You can extrapolate that any way you want to go, as long as the ratio is the same. The 3, 4, 5. Excuse me, 1 second. Yes, I'm in the middle class. What's up? Okay. Are you here? No. Hey, you guys, I'm going to introduce you to my wife. No, come on, I want to introduce you. Just say hello. Just say hello. Nobody's going to come in.
Who am I saying hello to? Hi.
Hi, how are you?
Good. How are you?
Good, thank you. Nice to meet you.
You too. I'm delivering a lunch here.
This is
Aw, that's so sweet.
Yeah, from the Santa Barbara Botanic Garden. Thank you.
Aw, she's gorgeous, Rodney.
Oh, you're sweet. Thank you.
I hired her for the day. I know.
You scored.
Okay, where was I? So do you have questions on that? I really kind of went off on a tangent on this XY coordinates, but I've had to explain it so many times, and most people don't get it because most people never used it. So if you have any questions, this is the time to ask, or we'll move on. But the hypotenuse, the Pythagorean theorem, the 3, 4, 5 triangle is how we find square generally in laying out buildings and in construction, period. Now we do X brace, we measure corner to corner. That also gives us square. But the 3, 4, 5 is how we lay out foundations to get square. And that's how the XYZ coordinates work. All based on the 3, 4, 5 triangle or the Pythagorean theorem. Okay, so let's do this. Okay. Now, okay. I'm going to show you a couple of other videos I made of Rich McCoy, who's an electrician. He's going to be talking about the electrical on this project that I'm doing right now. But before we do that, we're going to do a little demo. We're going to do a demo. Okay, and then we're going to do a demo, and then we're going to do a break. So I'm going to stop the share, go back to me, pin video, and hide you guys. Okay, so I wanted to do this last week, but because we've been talking about framing, I wanted to show you some of the options that you have to nail in framing. Wow, bad. Okay, here we go. Probably should have had John come over and be my photographer, but it's too late for that. So, can everybody see that bench so far? Yeah. Okay.
Yeah.
All right. So this is the one that you're probably the most familiar with. Are nails and hammers. So pretty much all the wall framing, all the stick framing, wall framing, roof framing, ceiling framing, and we'll talk some more about roof framing today. Floor framing, it's nailed together with 16 penny nails. Now they all have to be galvanized. But we used to drive these nails with a hammer, and this is a 24-ounce framing hammer. And this was the hammer that we'd use with a waffle head. That waffle head gives you a kind of grip on the end of the nail, so it slides off less easy. But if you miss, it makes a horrible mark on your wood. So that's why you use this for framing. So that stuff gets covered up and usually doesn't show. And one thing you may or may not know is that the end of these hammers have a place to put a nail. Just like that. I'm going to show you that up close. I think you can see that. All framing hammers these days have a magnet right there. It'll take a nail like that. So if you can't hold the nail like that, if you can't hold a nail like that, you can always, if you're doing overhead, you can always put your nail in like that, stop your nail. Was horrible. Hammer for a long time. So that's one way to nail. And you probably have all seen nailing that way, and you probably have all, I bet most of you have driven a nail. Some of you maybe haven't. So when I first started doing construction, that's what we did. We used hammers, and then compressors came on. They're usually bigger. Compressors compress air, make air available through hoses to drive a drive pin that will push a nail right in with the pressure of the compressed air. So to do that, we got to have a compressor. This guy right here, or something like that guy right there. And that guy right there has got a cord. So it's got to be plugged into one pin. So we're going to plug it in, and we're going to turn it on. So I turned it on right here. That's typically, it's a very typical compressor. That's what turns it on, turns it off to get the volume tank up to pressure. And then this right here, right there, that drains the tank. Typically, you want to drain the tank before, or if you're leaving the compressor. So, because in compressing air, moisture occurs.
Rodney, if you're talking, no one can hear you.
You'll be able to soon enough, as soon as the compressor goes off. So I'm going to not say anything until the compressor shuts off by itself. Okay, and it did. Okay. So now, can you hear me now?
Yeah.
Okay, good. So now we've got a gun that's loaded with 16 penny nails that are in a rack. Like that, 16 penny galvanized nails. These are 3 1/4 nails. Come on. I can't find the release on this damn thing. Jesus, there it is. Okay, So yeah, just release that, puts pressure, spring pressure, keeps driving the rack of nails forward. And then you saw how many hits it took me to drive that nail. That's how many hits it takes to drive that nail. So let me ask you, would you rather drive that nail by hand, or would you rather use this? I'd rather use this. But we have another way. We have another way of nailing. It's just come up in the last few years. And I bet some of you can guess. I was gonna walk over and get my battery, but I won't need to. Because John has lent me his framing gun. We have a finished gun. And actually, I'll show you this gun. It's a Simcoe. It shoots a 16 gauge finish nail, which is a nice finish nail. I cannot remember how these guys come in and out. Okay. So that thing drives, that Senko drives a 16 gauge nail. That's a 2.5. It'll go to 1 1/4. That's a 2.5 inch nail. That's the head on it. That's for doing finish work. We've been talking about framing. And framing, we're not going to use a gun like this. This is for finish. This gun is powered by a battery. And now it'll shoot nails, believe it or not. And so will this gun. Oh my God. Hey, John, do you know how much this weighs?
It's a little over 10 pounds without a battery. It's heavy.
How much with a battery?
I don't know. Battery's a pound or two. I don't know.
At least. Okay, so it's on single shot. So no compressor to turn on or deal with or maintain. No hose to drag around. Just which would you rather use? Now it's heavy. You're going to get some biceps using this. And I think some of our Ferrosex may have trouble wielding this, but it's sure a time saver. And Alex said something last week about he didn't think that a lot of framers use these guns, and especially nailing off sheeting because it can't keep up. But I don't think that's true. There's no air pressure to build up. It's got the same amount of power every time it drives that until your battery goes down. So I don't quite get it. I think you could use those guns to frame a house, and I sure would. If I could lift one for as long as it would take to do it.
This is Hugo. Quick question. How long does the battery last in one of those?
That's a really good question, Hugo. Thank you for asking that. John, can you chime in?
That has a 6.0 battery. I think that shoots maybe 400 to 600 nails, depending on the size, maybe a little bit more.
So however long it takes you, Hugo, to shoot 400 to 600 nails. Is that the larger of the batteries, that battery?
Yeah, that's a large, that's a 6.0 amp hour.
So they make smaller batteries,
Yes.
which would do less, but there should be literature on that, on just how many, but they're pretty much going to be not how long the battery will last, but how many shots it'll give you into material. Any other questions at this point? No, we're going to take a break then, so I can have my breakfast that my wife just brought over that you guys got to meet. I was pretty excited about you meeting her. I wish she'd have stayed longer. She could have helped me out. She could have filmed. She could have been behind a camera on that last bit. So let's take a break. I'm gonna get out of my pen here and go back to gallery. Okay, so we're gonna take a break. Right now I've got 5 after 10. Let's break for 15 minutes until 20 after 10. Okay, see you guys back then. Will somebody please, welcome back, everybody. It's 20 after by my watch. Let's see, did anybody, looks like, can I have Armando? Yeah, Armando is here. How about Emmanuel Gutierrez? Did you show up? Donna, did you show up? Dario, did you show up? Eric Garcia? D'Angelo?
I'm here.
Oh, Eric showed up. Good. Eric, when did you come?
What was that?
When did you come?
Like 20 minutes after.
Okay.
And then I'm here too.
And D'Angelo, you're here. Good. D's here. Good. How about Dario? No Dario, no Donna, no Emmanuel. Michael Silva? Dennis Vega? These are the greatest things ever. Look at these things. Thank God for toothpicks. I wouldn't want to live without toothpick. Okay. So I just wanted to go, I made a couple of notes on that. I had said some things, I'd mentioned some things when I was showing the video of the book building that some of you may not know about. 3 things: line sets, cantilever slab, and leach field. The whole concept of a leach field. Does anybody want to jump in and explain what a line set is as regards air conditioning? Okay.
Sure.
Okay, good.
So the air conditioner, the unit outside is a compressor, and it compresses a gas and pushes it to the air handler, and you can either pull heat out of the building or push heat into the building. And it has a condensing line and a return line, vice versa.
And those are the line sets, and they have to go from the unit, which in this case would be like a hung or a stationary forced air unit in a house, could be a mini split, to the condenser / compressor, and it's copper, big old, well, in the case of the job we're doing, Mango job, it's an 1 1/8" diameter copper pipe for the line set to carry that hot and cold air off. That's the line set. So every air conditioner needs a line set to run from the unit that's broadcasting the cold air, or in the case of a heat pump, hot air, and the condenser / compressor, which is always outside, always. And then we can talk if Jim's going to do any mechanical. I don't know if he is or not, but we can cover mechanical at some point. Talk about mini split, heat pumps, air conditioners, forced air units, gravity heaters. There's all kinds of ways to heat a house. Warm floors, which is what that house is going to get on the beach. And I would love to talk to you about warm floors sometime, and hopefully that house will get laid out. Pardon me? Hello? Who was it? Nobody? Anyway, I want to revisit those. I hope we have a chance during this class at some point, not today's class, to talk about methods of heating houses. And then that's going to be I bet it's going to be a good looking warm floor. And I'll get a video of that warm floor laid out before it's poured. And we can talk about how they're zoned and how they're laid out and what that is. It's radiant flooring with hydronic radiant flooring. That's heated water, heating the floor so the heat radiates. By the way, there's 3 types of heat. 3 types of heat transfer. Who can tell me what they are? Okay, here's the 3 types. There's radiant. That's when the heat is broadcast in a ray, like the sunlight. That's radiant heat. And if something is put in front of the sun, it stops the rays. It's not hot on this side. Unless it's something that's conductive. That's the other type of heat. That's the second type of heat transfer, conductive, because certain things conduct heat. They heat up and then they conduct it, and then the heat goes all along and through them. Like metal is a perfect example. Put a piece of a metal bar into a fire, get it red hot on one end, it'll be hot on the other end too. It conducts the heat. And then there's convection, and that's this heated air above an active fire. That's convection heat. Okay, 3 kinds of heat. Now to line sets, which John told us about right to a T. How about a cantilevered slab? I'll tell you about that with a little illustration. So that entry slab was a cantilevered slab. And if you give me a minute, I'm going to erase this blue, the 4 agreements, and I'm going to turn this heater off, even though it should go off any second. Somebody's got a cough.
You know, my mute keeps on going on. I don't know why it's not staying off.
Your mute keeps going on and off by itself. I hate that when that happens.
The shortcut for mute and unmute is the space key by default, and maybe if you're hitting the space key while you're typing, it's setting on and off.
Huh. Wow. Learn something new every day. That's a new one on me. So, okay, cantilevered slab, that particular slab. The building, pan deck, 6 inches of concrete put over a metal welded steel pan deck, right? That's the building. And then this is the ground below actually sloped off like this. So that slab tied to this slab, but it wasn't carried by this slab at all. It was carried by a cantilever, and it tied to the driveway slab here. This would be the drive. This would be the house. This sat on an 18-inch diameter, 15-foot deep caisson drilled down into the ground, 15 feet deep. 18 inches in diameter, full of steel and concrete, and the steel tied in and went this way. And so this slab is supported by this column down in the ground, and it cantilevers this way and this way, ties into the driveway and ties into the house. So it's dependent on its connection to the caisson down in the dirt, rather than dependent on the dirt, which there was none here. We couldn't build dirt up to it, right? Because the ground is way down here. The building's all cantilever. Down here is that little wall, carport down here, right? This is all cantilever. So we have nothing really to support this. So we had to do a cantilever slab. That's what a cantilever slab is. It's supported by one thing and then it cantilevers out. Now, a leach field. I'll bet some of you don't know what a leach field is. I have no way of knowing who does and who doesn't on that.
Okay, I'll give it a shot, Rodney.
Good. So Catherine, tell us, what do you think? What's a leach field?
Okay, a leach field is where first they process the waste, and usually it's human waste, and then they run it out on perforated pipes and let it absorb into the soil, usually in an open field, not close to people, so that it's different than being hooked up to the public sewer system.
Okay, that's a pretty good description of a leach field. I'm going to just take it a little further. Let's get this thing to focus again. Come on, focus. John said cover the whole camera. Is it focus yet? I can't tell. I don't
No.
think so. I don't think so. Come on, man, focus. There's a focus, a mocus. Okay, there we go. So, yes, Catherine, and it's leach fields are generally used in septic systems. So in a septic system, the house has its waste, its sanitary waste. That's when you flush the toilet, that goes to sanitary waste. When you take a shower or turn on any faucets, they go into a sanitary waste, which is completely captured, which either goes into a city sewer system or an approved sewer system like a septic system. So if this is a 4-inch waste leaving the building and heading downhill at least at least 1/4 inch per foot of fall, and it goes down and it comes into a buried septic tank of various sizes. The one over there at the book building was a 1,500 gallon tank. So everything that goes into this thing, right? And then it's got outlets. It's actually got 2 outlets. No, I take it back. I think this had 1 outlet that went into our 50-foot dry well, and that was connected to another outlet that went into our second 50-foot dry well, which are filled with gravel. And these are buried below grade, same as the septic system. So as the septic system fills up, right, solids stay down here, and eventually solids in a septic system will have to be pumped out. They don't leach out generally. It's the water that goes down that sanitary drain that comes up and fills up, and as it gets up to this level, it goes out and it enters the first dry well or a leach field. Same, a dry well and a leach field are pretty much the same, only a leach field would be something on a piece of property looking at a down view. You know, you'd come out of the septic, this is a plan view, and you'd come out into a field that was something like that, got all connected, and these would be trenches, maybe 8 feet deep, filled with gravel. And so that the water that comes up and overflows goes down and leaches down through this gravel, and then, you know, leaches out into the soil, goes all the way down. If it ever fills up, it would go into this one, and all the stuff would go down and fill up all the gravel and then leach into the soil. Because it's not a cased hole, it's a hole in the dirt filled with gravel. So the gravel would allow that water not to just fill up with water, but give it some time to stay in there and then leach out. And just leach out and go back into the ground and be purified through the groundwater. Because obviously the water that's in this septic system is not purified by any stretch. But aerobic and anaerobic bacteria would eventually make that water okay. Break everything down, break all the bad stuff down. So that's a leach field, and which I mentioned, and a cantilevered slab. Okay. Did that. All right. Okay, so we're gonna do. Yeah, I wanna share this screen with you, and I want to. I just want to go through a couple things, and I'm going to show you those videos of Rich McCoy. But I was looking at these this morning. Now, roof framing is probably my weakest link, except maybe electrical. So I count on framers to do it right. I know enough about it, and I know enough about roofs and bird's mouths and tail cuts and ridge boards and hip rafters and valley rafters and common rafters and all that stuff that I can navigate through construction, but I wouldn't want to be left alone to cut a roof in any kind of a time frame that anybody was counting on. So let's just let's look at this. I thought this was a pretty cool animation. Let's look at this animation. Right now, we're going to CC it, make it big.
These step
CC
offs
is
are
not
not the most common method used for laying out rafters.
Say again, please.
CC is closed caption isn't on. You got to click it and
I
then
did
click
it.
English.
Did it already. Oh, you're right. Sorry. Thanks. Thank you. Thank you, John.
But this procedure may be useful in certain situations and helps to illustrate the connect between unit rise, unit run, and rafter layout. In this example, we will use the step-off method to lay out a rafter for a roof with a total run of 6 foot 8 inches, a slope of 5 and 12, and an overhang of 1 foot 10 inches. Begin by marking the unit rise and unit run on a framing square. Place the framing square near one end of the rafter and draw a line along the tongue. This line represents the center line of the ridge. Next, lay out the partial unit of the total run, which is 8 inches in this example. Place a mark at 8 inches on the blade of the framing square. Move the framing square so the tongue aligns with this mark. Now place a mark at the 12-inch mark on the blade. Repeat this step-off process 5 more times to measure the total run of 6 foot 8 inches. At the last mark, draw a line along the tongue of the framing square. This line represents the building line. Draw the seat cut of the bird's mouth using the blade of the framing square. The length of the seat cut matches the width of the top plate that will support the rafter. Measure the overhang from the building line by stepping off the full unit and the partial unit. Cut along the overhang line. Finally, the top of the rafter must be offset for the thickness of the ridge board. Offset the ridge line by 1/2 the thickness of the ridge board and draw a line. Cut the rafter along this line and the rafter is complete.
Wow, I love it. That was great. This animation is pretty helpful, I think, really. Roof framing is relatively complex. Does anybody disagree with that? All right, good. I was hoping not, because it's complex for me and I've been doing this a while. But I do understand that step-off method. And if we have time today, I'm going to show you a stair stringer layout for cutting stair stringers for job site stairs or really any kind of stairs. And we'll do a similar step off and we'll take total rise, total run, and we'll turn that into unit rise and unit run. But in the meantime, let's look at making ridge and tail cuts.
The length of a hip rafter is normally determined using a rafter table. However, this length is measured to the center line of the ridge board. To make the ridge cut on a hip rafter, begin by marking a line based on the hip rafter length. This line represents the theoretical endpoint at the center line of the ridge board. To find the actual end of the hip rafter, you must offset the diagonal distance from the center line of the ridge board to the edge of the ridge board. Measure or calculate this distance, which is 1 1/16 inches for a 2x ridge board, and then offset the line on the hip rafter by this distance. This line represents the tip at the center line of the hip rafter. The hip rafter cuts are made at a 45-degree angle from the center line location. One method of drawing these cut lines is by offsetting the line by 1/2 the thickness of the hip rafter. The cut line on the top of the rafter extends from this line to the center line of the rafter. Repeat the cut line on the other half of the rafter. Cut along the lines to create the ridge cut. The tail cuts for a hip rafter are also made on 45-degree angles. After marking the rafter end based on its length, measure back 1/2 the thickness of the hip rafter as you did for the ridge cut. The cut line on the top of the rafter extends from this line to the center line of the rafter. Repeat the cut line on the other half of the rafter. Cut along the lines to create the tail cut.
So because it's 45 and because hips have 45, you really don't have to measure halfway back. You can just use the 45 on your speed square. But by measuring half of it back, that's just giving you a 45. Oh, that was it. Huh. Okay, let's look at using a framing square for jack rafters. Here we go. Oh, yeah.
Hip jack rafters are short rafters that run between the wall plate and a hip rafter. Hip jack rafters run parallel to and are separated by the same spacing as common rafters. When hip jack rafters are equally spaced along the plate, the change in length between adjacent rafters is consistent. This distance is called the common difference. The common difference can be read from a rafter table. For example, for a roof with a 5 and 12 slope and rafter spacing of 24 inches, the common difference is 26 inches.
Wow.
The common difference can also be determined using a framing square. To use this method, begin by marking the unit rise and the unit run on the framing square. Place the framing square on a board and draw a line along the blade. Slide the framing square along this line until the rafter spacing value is reached. At this point, mark at the tongue of the framing square. The distance between the two marks is the common difference.
Oh, wow. Y'all got that, right? I thought so. Yeah, I'm having a little trouble following it. This takes some going over, but hopefully you're getting some of the concept. This one I think is really good because it talks about roof types, and that's something that that isn't all that complex.
You should be familiar with the most common types of roof frames. The gable roof has two surfaces that slope down from the center.
Most common.
The ends form triangles or gables. A gable roof's functional design and low cost make it the most common type of roof frame found in residential construction. A gambrel roof, a variation of the gable roof, has multiple slopes or pitches to provide more space in the attic. The gambrel roof is a traditional style typical of colonial America. A hip roof has all four surfaces sloping away from the ridge. The angles formed where the roof surfaces meet are called hips. A hip roof provides overhang over the end walls. The mansard roof, like the hip roof, has four sloping sides, with each having a double slope. The main advantage of the mansard roof is the additional space gained in the rooms on the upper level. A shed roof, also called a lean-to roof, is similar to a flat roof, but has a slightly steeper slope. This roof frame is often used in contemporary home designs. A dormer is a framed structure projecting above a sloping roof surface and normally contains a vertical window unit.
Nice looking dormer. Some roof terminology. Here we go. Ready, set, go.
The slope, or pitch of a roof, is the angle formed by the roof when viewed from the side. The ridge is the horizontal member along the very top of the roof. The top of the roof slopes, or rafters, meet at the ridge. Rafters are sloped framing members in the roof frame. Common rafters are long framing members that run at a right angle from the wall plate to the ridge. The valley is the trough, or internal angle, formed by the intersection of two roof slopes. Valley rafters form an internal roof angle. Hip rafters run at an angle from the plate to the ridge. They form the roof frame where the two slopes of a hip roof meet. Roof framing is a practical application of geometry. It is based largely on the properties of the right triangle. The base of the right triangle formed by the rafter is called the run. It is the distance from the outside of the plate to a point directly below the center of the ridge. The altitude, or rise, is the vertical distance from the top of the plate to the point where the rafter measuring line meets the ridge center line. For example, a roof that rises at the rate of 4 inches for each 12 inches of run is said to have a 4 and 12 slope. A triangular symbol above the roof line in the architectural plans gives this information. Pitch is the incline of the roof as a ratio of the rise to the span, which is twice the run. It is given as a fraction. For example, if the total roof rise is 4 feet and the span is 24 feet, then the pitch is 1/6.
Oh, okay.
Rafters are constructed by laying out and making various saw cuts based on the house plans. The ridge cut allows the upper end to fit tightly against the ridge. The bird's mouth is formed by a seat cut and plumb cut when the rafter extends beyond the plate. This extension is called the overhang or tail. The framing square, also called a steel square or carpenter's square, is the basic layout tool in roof framing. Some framing squares have thumb screw locks, so you can set the square to the home's roof pitch. Once the thumb screws are locked at the correct roof pitch, you can quickly fit the square over the rafter, and the stops will hold the square's correct graduations on the rafter for marking cuts. As you lay out rafters, try to visualize how each will appear when it is set in the completed roof frame. Forming the habit of visualizing the rafter in its proper place will help to eliminate errors. Rafters are constructed by laying out.
Do we do cutting rafters?
Sight down each piece of rafter stock to find the crown. Mark the crown so that all rafters will be cut and installed crown up. Reject any stock that is badly warped. Lay several pieces of stock on your sawhorses with a crown oriented properly so that they are all ready to be cut. First, lay out the rafter ridge cut. Place the framing square on the stock as shown. Align the appropriate numbers for the unit run and rise for the specific roof pitch. Starting at the top of the rafter, position the square and draw the ridge line along the edge of the tongue. Use your circular saw to make the ridge cut. Using the diagonal dimension from your framing calculator, measure along the length of the rafter to mark your bird's mouth plumb cut. Form the bird's mouth by drawing a horizontal line, C-cut, to meet the building line, so the surface will be a little larger than the width of the wall plate. Your rise and run in your framing square should be the same. The size of the bird's mouth may vary depending upon the design of the overhang. To lay out the overhang, start with a plumb cut of the bird's mouth. The tail cut may be plumb, square, or a combination of plumb and level. Check the cornice details shown in the architectural plans for exact requirements.
So these are factory-built trusses as opposed to site-built trusses.
Roof trusses have the rafters, ceiling joists, and integral bracing pre-assembled before being delivered to the building site. Roof trusses are installed as complete units. A crane is often used to lift the correct number of trusses onto the wall frame for that section of roof. First, the two outer trusses are nailed in place. Then a 2x4 is nailed across the outer trusses. The wall top plates and the 2x4 brace are marked on center. Each truss can then be slid in place and positioned next to its on-center marks on the walls and the brace. The truss is then nailed to the brace and to the walls.
Shit, sorry. Okay, let's do these. Which one is this? Nobody? That one? All
It's-
right. It's a gambrel. How about this one?
The hip.
Very good. How about this one?
Dutch.
Very good. This one?
Shed.
Shed.
Very good. This one?
Mansard.
Very good. This one? Yes, gable, actually, you're right. And then by process of elimination, that looks awfully flat, doesn't it?
A little bit.
Woohoo! We did it together. Good work. Okay, what else we got? Okay. What is this right here?
The gable.
There, very good. Very good. How about right here? What's this?
Valley.
Very good. This here?
Hip.
Hip.
And by process of elimination, ridge. Good
Ridge,
job. Let's
uh-huh.
see if you got 'em right. Yes. Okay. Vocabulary game. Framing members. Did we just do rafter terms? No. Or did we? No, we didn't. Okay, this is a good one too. All right, what do we got? What's this here and this here?
That
Exactly.
is plum cut. Yeah.
Okay, what is this?
Ridge.
Very good. How about this?
Line length of rafter.
Okay. How about this?
Double plate.
Very good. How about this here and here?
Sea cut. Bird's mouth.
Bird's mouth. Yeah.
Is that the seat cut? Yeah. Okay.
That's the seat right there.
The wrong place.
Okay, what about, what's this one?
Is that the tail?
L.
This one?
The overhang?
Uh-huh.
Or Eve? And then this one we're calling bird's mouth. I wonder if we haven't got seat cut and bird's mouth.
Yeah,
reversed.
those are.
Yeah.
Yeah.
It's kind of what I thought. Okay, so we know that that's seat cut and that's the bird's mouth. Good though, you guys are doing great. Okay. Okay, basic terms in rafter layout. Let's start with, what's A?
Overhang,
What about B? What's B?
line length of rafter.
What is
Would be
E?
D.
E,
Yeah. What's E?
rise,
How about G? What's G?
span,
How about F?
run,
How about C?
center line of ridge.
Very good. H?
Plate,
And D, the last one. I suspect we did good on that one.
Yeah.
Terms and after layout. Okay. So this is a Fink truss, and we're going to identify its truss members. We didn't talk about this or see it, but let's see if we can do it. So, what's this guy here? This is the easiest one.
Bottom chord.
There you go. Atta girl. What about this one here?
Top chord.
Very good. I mean, that's what I think it is. What about this one? I guess it's here.
tail with that return option.
Yes, it is. I didn't see the return option. What about this one?
There's just the tail option.
Very good.
Yeah.
Very good. Now, how about this guy here?
Compression web.
Compression web, yeah.
And this guy here?
Tension web.
And then by default, that one goes there. That's plumb cut on the rafter end, and we did it. Excellent work. That was really good work. And I think we've done that. There is let's see. Now that we've been through that, let's do some flashcards. We'll just go through this. We'll do the last three here. It's kind of fun. This kind of embeds this stuff. Okay, so a bird's mouth. Could somebody just say something about a bird's mouth?
Is the C cut on the plates.
On the end of a rafter as it sits on the double top plate, right?
Right.
Notch cut on the underside of a rafter to fit the top plate. If the rafter end is flush with the top plate, the bird's mouth is not a full notch. Okay. Camber. Who knows what camber is? I think camber is I think it's the built-in crowning of a beam. Let's just see. A slight arch in a beam or other horizontal members so the bottom of the member is straight when under load. Yes! All right, here we go. What's a collar tie? Come on. I know you guys know this. Somebody knows it, you guys and gals. All right. Collar ties are also ceiling joists. Ceiling joists are collar ties. And what a collar tie does is it goes from plate to plate in a wall run and from one side to the other of a roof over a structure. You have to have a collar tie plate to plate. And what it does is it helps keep the walls from falling outwards with the pressure of the roof on it. If you imagine with no collar ties, just walls standing, if you had all that pressure on the roof, your walls could conceivably start moving outboard. With collar ties, it keeps it all together. Collar ties, ceiling joists. So when you don't have when you have a volume ceiling, when you don't have ceiling joists, and you just say you don't have trusses that have bottom cords, which basically are collar ties, then you have to do some things like usually up your rafters to a larger rafter, and you definitely up your ridge from a smaller ridge board, like ridge boards can be 1x or 2x, but they're usually go into 4 and 6x. And that's all part of the engineering, which I don't completely understand, but so a collar tie is a tie beam connecting the rafters is located considerably above the wall plates called a rafter tie. So rafter tie, ceiling joist also works as a collar tie.
Can I make a comment, Rodney?
You may.
Especially in the book, which is a little different language than we use here on the West Coast, I think. When they refer to a collar tie, they're referring to a piece generally in the top third of the rafter.
Okay.
And then the rafter tie is what we call a collar tie here. It's kind of backwards of what.
Okay, so a rafter tie. So a rafter tie is not really a ceiling joist. It's up above the ceiling joist and connects the rafters. Good. Okay, I like it. And if you have ceiling joists, you don't need collar ties generally. So common difference, anybody want to explain that? That's when you're laying out a roof, say it's 5 1/12 pitch, and you come up with the common rafters spacing, or I'm sorry, it's not, wouldn't be on a common rafter. It would be the common difference on a hip or a valley jack, because they're going to get descendingly smaller or bigger depending upon which way you go on the valley or on the hip. And there is a common difference, and you can figure that out. Let's see how they explain it. The difference in length between any two adjacent studs or rafters when laying out a gable end, frame, or hip roof. I don't know if I confused you or not, but there's their answer. A common rafter. Somebody want to tell me what that is?
A rafter connected to both the ridge and the wall plate.
That's exactly correct. What? Did you cheat on that one? Did you peek?
Yes.
I thought so. Okay, cornice. What's a cornice? Should be the eave or overhang, right? No, it's not. Exterior trim of a structure at the meeting of the roof and wall. Usually consists of panels, boards, and moldings. It's also an exclusive term for all the parts that enclose or finish off the overhang of a roof at the eaves. That's why I was thinking of eave. When you box in an eave and finishing it off, that's called the cornice. But the cornice is also can be a decorative part, usually on the, you see them on gable ends. Let's see. At some point, if anybody's interested, we could probably pull up an example of a cornice. Cripple jack. What's the cripple jack?
Are those the cripple studs?
Well, a cripple jack would be a jack rafter, and it should go from the plate to either the hip or a valley. Let's see. Oops. It's a rafter that intersects. Okay, so it goes from a valley to a hip or a hip to a valley. It intersects neither the wall plate nor the ridge, and it's terminated at each end by a hip and a valley. So if just the rafters that just go between hips and valleys are called cripple rafters, valley cripple jacks, or hip valley cripple jacks. Try to say that fast. Hip valley cripple jack. All right, who can explain dead load? Okay, so in a roof and a floor, when you sheet it, the sheeting and the rafter, the whole roof system is engineered to achieve a certain strength to carry its dead load and its live load. So a dead load is the weight of the framing and the sheeting and the nails and everything else that's going on that roof to create the roof. That's the dead load. And the live load, which will probably be next, are the forces like snow, wind, rain that people standing on it that can affect it. So dead load. The weight of permanent stationary construction and equipment, including in a building. Oh, okay, didn't go right to live load. So a dormer, let's just see what it says about a dormer, is a frame structure extending from and fastened to a roof slope and having a roof of its own. It provides a wall surface for installing a window. They showed some nice pictures of dormers. All right, an extended rake. Who wants to tackle this? You can do it from the book. It's okay. Catherine, what's an extended rake?
I know.
I think it's a rake roof that extends to make an eave. Let's see.
A gable overhang.
There you go. It's exactly what it is. So each side from the ridge of a gable is a rake, and it comes out, and when it goes past the wall plane, then it becomes a gable overhang. The extended rake. Okay, what's fascia? What's fascia? Colby, you know what fascia is?
No.
What was that?
Okay, how about Josh? Do you know what fascia is? No? Kevin, do you know what fascia is?
No.
I sort of, the exterior, that's when fascia is the outside.
Well, no, in this particular case, I'll bet this is what it means. The fascia is the trim that goes on the ends of the rafters. Let's see, oops.
Oh, the fascia is a trim?
Yeah.
Okay.
Wood member nailed to the ends of the rafters and lookouts. Lookouts are on your gabled end eaves, right? So when you have an eave on the end of a gable end, not on the end of the rafters, those get lookouts so you can extend out that roof out over and create an eave over the gable end. And fascia runs at the ends, it captures the ends of the rafters, and it'll run out the lookouts as well. So the fascia is at the rafter ends, and it's also used as the outer face of the box cornice.
Sorry, this is the interpreter. This is Lindsay. I don't know what you mean. Can you say that in different terms?
Which didn't you know? Which the box cornice? Is that what you're having trouble with?
I'm just trying to interpret that concept, but I don't understand what it means.
Okay, so how about you got rafter ends, right? What rafters are and the ends of rafters?
Yeah.
So as rafters end, they go over the wall, they overhang, and then they end, and on the end of each rafter, a board is nailed to the end that finishes off the ends of the rafters, captures the ends of the rafters, and shows a horizontal board on the rafter ends. That's a fascia, okay?
Got it, thank you.
Rodney, okay, yeah, I'm having a hard time hearing you. I don't know if your volume needs to go louder, but I am having a really hard time hearing you.
And who is this?
It's the captioner.
Okay, how about now?
I hear you good.
Yeah, does anybody else have trouble hearing me?
No.
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 Linda, do you still have trouble hearing me? Linda?
You fade in and out.
Okay, I'm
Maybe
sorry.
your internet.
Pretty sure
No,
that's-
it's not my internet. My internet is fine. Everyone else is fine. For some reason, I'm having a hard time hearing Rodney. I can hear everyone else.
I wish I could help you there, Linda. I just don't quite know what to do. And I'm not sure what to do. I'm just gonna keep going unless somebody can suggest something. Do you want me to go in and take you out and then start you over again? Did it get worse? Was it ever good? Linda? Was it ever good?
No, I think the fact that you're talking at 340 words a minute is against the speed limit of my ability, which is only 240 words a minute. So I just think that's the problem.
Okay, but Linda, that's not what you said. You said I was cutting in and out.
No, I don't take me out because that's just going to cause more technical difficulties.
And Linda, word of the wise, please don't ever tell me what to do.
Oh, I didn't mean to tell you what to do.
I know.
I just said.
Linda, I'm just pulling your leg, but
All
so
right, I think I'm going to unmute myself and let's see how we can go from here.
okay, but I just want to make sure that you can hear me. I'm going to assume you can hear me then. All right, so a fink truss. It's a kind of a truss. Let's see what this says. It's a roof truss that can be used for spans up to 50 feet, also called a W truss. And I think your book shows you an example of a fink truss that has a looks like a W for the kickers that support the top and bottom chords. A flat roof. Anybody want to tell us what that is?
Just the roof that's flat.
Yeah, flat. So How does water get off of flat roofs?
It's not a
You know?
It's a very low pitch roof, 1/4 inch per foot to 1 inch per foot.
A flat roof actually does have a little pitch or I might add, and usually flat roofs are framed flat and then the buildup or the pitching is done after the roof is done to shed water off a generally flat roof. But also you might see a flat roof that is sloped to various drains too, or have a parapet around it. But yeah, a flat roof is not ever dead flat. A roof that is either level or pitched only enough to provide for drainage. So rarely would you find, I mean, you might find a very, very small roof dead flat, but if it's dead flat, and really flat with no dips at all, you know, it's not going to hold water. That's for sure, right? You can't. But good luck on it. Excuse me for 1 second here.
Sure.
Try to. Well, I'm right in the middle of class. I'm sorry, I gotta go. I gotta turn this off. Sorry about that.
No problem.
I just keep thinking it's one of you calling me. All right. A framing square. I guess we've seen a framing square. It's a square with a short section called the tongue. It's attached at right angles to a longer section called the blade or body. And there are a number of tables imprinted on its side, also called a rafter square. It's really a cool thing. And I don't know that we're going to have time today, and maybe we will. I'll have time to step off and show you how one works to lay out a stair. We'll see. I haven't got those videos yet, so yeah, I don't think I'm going to go through the whole thing. And I think was someone chiming in? No? Okay, I think I'm just going to go through these for now. We'll move through a few of them. A gable roof is that roof that is a roof consisting of a single ridge with slopes in both directions, made entirely of common rafters. A gambrel roof, a roof slope formed as if the top of a gable roof is cut off and replaced with a less steeply sloped cap. This cap has a ridge in the center. A gusset. This is a good word. Can somebody tell me what a gusset is? No? Okay, let's see what they say. Gusset is a plywood or steel plate fastened to the outside of a joint to give the joint strength. Now, if you look at when we show these videos of McCoy on the Chellam job, there are gussets at the bottom and tops, plywood gussets at the bottom and tops of all the site-built trusses. I'll point them out to you. Hip jack. Jack rafter goes from the plate to the hip rafter. I'm sorry. Goes from the hip, it goes from the plate to the lower part of a common, but it intersects a hip rather than goes all the way to the ridge. A hip jack rafter is a short rafter connecting the wall plate to the hip rafter. A hip roof is a roof that rises from all four sides of the building. A hypotenuse. Who can tell me what the hypotenuse is?
It's the, on the right triangle, it's the longest point.
Long end of a right triangle. Very good. The side of a right triangle opposite the right angle. And roof framing, the length of the rafter is the hypotenuse of the triangle formed by the rafter and run in the rise. Okay, a king post truss. I'm sorry. Did you have a question? No? Okay. A king post truss is a roof truss with top and bottom cords and a vertical center post, and it's used in shorter spans up to 22 feet. I think there's examples of that in the book. Live load. Here's live load. Okay, so remember what a live load is? A live load are the things like All moving and variable loads that may be placed on a building, wind, snow, rain, people. You got to figure a live load. There's a formula for figuring the live load of people on a floor. And I don't know what it is off the top of my head. A lookout, a lookout should be it's a framing member that extends at a gable end to give you an eave. Let's see what they say. A structural member that supports the soffit and runs between the lower end of a rafter and the outside wall. Okay, I can't explain that any different. I'm a little confused on that one. Let's hope the book can explain it a little better. A mansard roof, pitch. We know what pitch is. Pitch is the ratio of the rise to the span, and the span is twice the run. That's pitch. What's a purlin? Purlin is a horizontal roof member used to support rafters between the plate and the ridge board. It's a horizontal roof member used to support rafters between the plate and the ridge board. So they would run across the rafters and help give added support. Rafter, one of a series of structural members of the roof, is designed to support roof loads. And then number 30, the ridge, is a horizontal line at the junction of the two edges of two roof surfaces. We're going to leave off at number 30 there. Let's go over to the Shellam Road job, and let's talk to Rich McCoy. He's a really great electrician, has a great electrical company. Okay, we're recording now, and we're recording at the Mangone job again, and you are looking at Rich McCoy of McCoy Electric. So Rich, could you just tell us a little bit about you and your company, when you started, stuff like that, and how you became an electrician?
Well, think back now. Right out of high school.
Was it something you were interested in, or was it just a job that was available?
Yeah, summer job, yeah. I was working, I quit my job to go
Let me give you this. Sorry about the finger. God, I got to learn how to not do that.
sports, and then got cut from sports. Baseball team didn't make it after all, so then I was looking for a job. So I went and got a job after school as an electrician.
So just out of curiosity, did you start? He looks like a baseball player, doesn't he? By just clean up and stuff like that? Or did you start pulling wire?
As a helper. Yeah, I mean, obviously, you follow around and ask questions.
Yeah. And, oh, I forgot, electricians, they don't clean up after themselves. What am I thinking? Picking up stuff, nah, that's somebody else's job.
We used to warehouse in snow, so probably at the beginning of the day, we shoveling snow and then, getting warm and then getting clear space and then start.
When did you think you were gonna make a career out of this? How far into it?
Never knew what I wanted to do, but, it's interesting. I think in a lot of careers for everybody, once you feel like you're good at something, then it's maybe more something you want to do than it is before you did it. You didn't know you were good at it. It wasn't something I dreamed about, it's just something that happened.
So you started your own company, you get a contractor's license first?
Before I started my
Yeah,
company.
yeah.
Yeah, no, so I worked for people for a lot of years and then moved here in Santa Barbara and worked for some guys here, and then started my own company here when they retired in '92. Started my company in '92, and in '92, I guess, and then it's been here ever since.
What's the bulk of your work? Is it pre-wiring new construction?
No, we really do it all. I mean, they used to say, 50-50, 20-50, whatever. I mean, it just goes in cycles. Sometimes we're doing all commercial, the next time we're doing residential commercial. I mean, our specialty is home automation, and it has been since I started. I started with a company as a helper doing houses that had automation in them, and I moved here to Santa Barbara. A lot of the houses had automation. We were doing automation when companies didn't do the whole thing. We had to integrate, 4 or 5 or 6 different companies to make it work. I had to kind of invent things. And now, these automation companies, a lot of them are doing the whole thing. So it's got
could you explain just a little bit what is home automation?
You know, from your phone, I mean, people are starting to get to know it now, but back in the 90s, they didn't, but, you know, from your phone or from your internet, we can, you know, open your curtain, lock your doors, turn on your TV.
Turn on your lights, turn on your microwave, your
Right, I mean, even
your
some
oven.
appliances, we have some now, and now even with the AV stuff, you know, we have, well, reboot your routers and reboot your AV equipment, for you, for the customer, to cycle it without them, you know, having to go find. the
So
breaker box.
remotely, you can do that remotely. Wow, that's incredible. So if I understand it right, your business, it seems to me, you do electrical work wiring new houses, wiring remodeled houses, like standard, you know, duplex outlets and lighting and stuff like that, as well as home animation, all the AV stuff, the TV stuff, the sound stuff, all that jazz, right? You do, I've seen your trucks do, your boom lift do like outside lighting, like
Yeah,
Italian lights and stuff like that, parking lot lighting.
Commercial buildings, we do, you know, parking lot maintenance. Or, yeah, temporary power poles, if they need it for job sites, we don't really push that, but we do.
Solar
Yeah,
arrays.
Solar, you know, there's so many solar contractors out there, we've been so busy, we haven't really pushed that either, but we do it, or we have done it.
Yeah, you did Ted's solar, right? Yeah.
Yeah, I think we won an award on that one or something at the time from the city at the time.
How many KW is that? Okay, well, it's a nice looking array. I saw it today, as a matter of fact, and was asked about it.
Yeah, so it just evolves. I mean, it's like from one thing to another, you know.
Yeah, it does. And I mean, if you're in the place to get the work and do the work, then that's where you are, and that's what you do, right?
We're fortunate to be in Santa Barbara, in California, where people want those things, and the sun's out, and they have the means to do it, and if they want it, you know, we try to do it for them, whatever that is. You know, I have people that have left working for me and gone to other schools and call me back and say, "Wow, you really set me up." You know, they don't do any of this out here. They have no idea. I'm like king, big man on campus out here. You know, they have no. They just aren't doing any of it. So it's really
Cutting edge West Coast technology, baby. Now, this house, 966 Chillum Way, Mango, and I can give you the address because I've filmed it more than once. But it's all new electrical. Could you briefly describe electrical? I'll just preface with saying that the set of plans is pretty light on electrical details, to say the least. But so Rich worked with myself and the owner to put in the electrical details that needed to happen. And I initially did myself because I knew we wanted a new 200 amp panel. 100 amps was not going to cut it on this job. But just tell us a little bit about, if you would, this particular job, and how it went for you.
You know, as a lot of the remodels do, you know, they show existing stuff that wants to remain, but the reality is, with today's stuff, you're better off just removing that, start fresh. So we started fresh and ran everything new, completely new.
We had some knob and tube in here too, right?
There was some knob and tube in here, and old wiring. And by the time you modify it and try to attach back onto some old circuits, whether it's knob and tube is definitely out, but it's installed it. So new circuits all the way through, appliance circuits the way they should be, weatherproof outlets, you know, dedicated circuits on the outside, whether you have spas or air conditioners, Tesla outlet or car charging outlets now, the future solar conduits. The attics or roofs are mandated now to have 2 spare spaces in the panel and a conduit to the roof.
Really, where are we putting that? Are we just doing a stub for that then? Is that what we're doing?
So we have, empty conduit up to the roof line to where a solar contractor could come in later and put solar on. Now, I think I don't even know how it reads, but the new rules are that you have to actually put the solar on the roof. I think this being built when it was, we were prior to that.
So will we just have a stub up there, or will we have a box up
Conduit
there?
to the attic, and then from the attic, the empty box, empty conduit.
And then he could come and make the roof
He can
penetration.
extend it to wherever he wants it and make the roof penetration.
But that's code these days. You gotta have empty conduits to the attic. And where else do you have to have? You said something just.
Car chargers, I think they're mandating either a car charger outlet in the garage and they're mandating a solar roof.
Wow, cool. It is, it's the way we're going. So let's just see this job here. I know you've been working with the owner on lighting. And I think you did show duplex outlets. You have some code requirements that dictate that you have to have a duplex outlets and how many or how often, is that correct?
No more than 12 feet apart. They use kind of this 6-foot cord rule on your vacuuming, go 6 feet either way. But it's as the wall flows, not across the room, not diagonal, whatever. It's actually as the wall goes. So every, less than 12 feet apart as the wall goes. Any wall more than 2 foot wide needs an outlet on it, which is.
Wow, really?
That's new, but it's newly enforced. They're getting a little more strict about that. So sometimes you end up with a lot of outlets on the small walls that people don't.
Yeah. But code says if it's over 2 foot wide, you gotta have an outlet on it.
Yeah, hallways, I think you can one for hallways, so hallways don't necessarily count. And sometimes they count behind doors as not counting as your wall space because the door's always there. Yeah, a lot of people don't want outlets. We just don't want. I mean, we get designers who don't want outlets anywhere on the house, and they take them out. But the building department requires them to put them in. You have to have at least one above the counter in the bathrooms above the outlets. So we used to have designers who would like to put them down below the counter, so we wouldn't see them, and they want to see them. But the code says it needs to be above the counter.
Closets too have to have lighting too, don't they? Is that mandated by code?
Let's go. I don't think so. We don't put closet. We don't put lighting in every closet. We have people that want them, and we do put in a lot of closets. And there's rules about where they can be in the closets, but we don't put them in every closet.
Where and what too, so they can't have any fixtures that generate a bunch of heat.
Right. They used to 12 inches out front shelf, which we still do, and they used to all be heat and light bulbs and worry about fires, people stuff in the top shelf.
And besides electrical, I mean, electrical being the 110 that comes from, I'm probably gonna get this sign in your face, or 220, I take it, that comes from the pole, in this case, down a wire, not underground, which it would be in some cases in conduit, to a masthead, and then down into the box, 200 amp box, which powers up duplex outlets for anything you might plug in. All your plug-in electrical stuff like refrigerators and appliances that stay plugged in. But besides all that electrical requirement and switch legs, the AV stuff has got to be, AV and data, especially data, has got to be a pretty big part of your of the job these days. I mean, everybody wants data, right?
Yeah, I mean, it used to be almost more because we had to run wires. We're in the future with now that Wi-Fi's really gotten good. We can do a lot of stuff wireless, but the reality is if we can get a wire there, we try to anyways because it's a better service. But yeah, TVs, all the TVs are run on the network. I mean, cables kind of go into streaming, so that's happening, and phones and iPads, and everybody's streaming everything in the house. So, the old wires just didn't cut it.
Nope. And this blue, this is all data here, right?
This is all, this is all.
Typical cat, is it Cat 5 or Cat?
Yeah, Cat 6.
Cat 6 now, yeah.
Cat 5 and Cat 6, and they'll have a rack on the wall with the internet switch and modem and probably even that cable box.
That'll be that box?
It's actually going to be, on a hinged rack up here.
Wow.
This is the utility company coming in, a place for them to disconnect.
Disconnect. So there's the back of our 200 amp new panel with all the Romex and cabling pretty much done. And look at these really cool. I love these. What do you call them?
Home run helpers or
home run helpers. Look at that. And they're all the way, I noticed they're all the way through the attic. You can see one up in there to just keep the wires routed in the right direction and keep them separate from each other, right?
So you're not allowed to have more than 8 current carrying conductors in a hole anymore. I used to jam them all in one hole into the panel, but for heat, they can't travel very far together. I think you can get them together for a short distance, but
no more than 8 in any hole.
Carrying conductors, so that's really only 3 of the yellow wires, potential. So if you see more than 3 wires through a hole, make them out. And that's not what they did for years and years.
Well, what about keyless fixtures? Anything about this job in particular? Well, look, there's Adrian. Adrian works for McCoy. Yeah. let you open that one. If you wouldn't mind. Wow, that's a beautiful, now that's a pretty standard 200 amp panel, right?
Yes.
Meter socket.
It's reversed in the fact that the meter's at the bottom. Square D's made this new one that puts the meter at the bottom and changes the height of this stuff, but
And it's the meters at the bottom because it would be a bit hard to read.
right, and the main breaker's down here, so your main shutoff's low, and then that's high, it gives more room space to get out, but you can also come out of it later on the surface. It leaves the ability to do
Yeah,
that.
cool. And what the heck else was I gonna say about that? Meter panel. This is a smart meter too, right?
This is a smart meter. Yes.
Yeah. So they don't have to come and read that, they read that remotely.
Right, and I think, I don't know if everybody knows it, but I think you can log into your smart meter, I think with your bill and look at your usage or your highest point of use at any one time. You can see, I've only drawn 110 amps at it, it might not be an amp, it'd be under kilowatt hours, but kilowatts.
But you can see that, you
But
can
you can
plug
see
in.
that online
Huh,
if you log
cool.
in yourself, and not
If-
all of them do, but you can have it turned on so you can.
Yeah, Edison, what a company, man. I swear. So let's walk through, let's go in and walk through and just,
Get in there.
if there's anything, anything you can tell us about the electrical in here that's unique or just something that catches your eye. So one thing you don't see is you don't see any ceiling in here, right? So since there's no ceiling, there's no, what you might see in here, which is recessed cans, which is we're so used to seeing in a variety of shapes and sizes and configurations, and there won't be anything here. Our owner does not like recessed cans. So she's gonna have some kind of a track system, is that what we've decided?
Yeah, so we're
And
gonna
we
do
have
a dual circuit track on the side of the truck. Running, I believe on the side of these trusses with some energy efficient LED, high efficiency lighting aiming up and down. So you'll get enough light with the glow, and then you'll have some task lighting aiming down on the kitchen counters and around. It's a unique.
So there's nothing to stub for us from Russ. Those Romex stubs there are what we're talking about, right?
Yep.
Coming out
They'll be
underneath.
at the end of your track, and then the tracks are gonna come along the trusses and hopefully blend in, maybe paint in whatever
Yeah.
as well as we can.
Alongside, I think at this point, we're talking about taking off, we're going to clean these guys up prior to paint, but we're gonna take out these plywood gusses and replace them with some solid gussets. Oh, look a little there. But this is the look here, but at least see, so, what about, all this is wrong. I was asked the other day about Romex, the difference between the yellow and the white Romex.
So the yellow Romex, they started. It didn't used to be that way. They changed the colors. Yellow is now 12 gauge. The white is 14 gauge.
And it's all three wire, right? Neutral, hot, and ground?
Well, yeah, some is 4-wire, and so the new stuff has 2 neutrals and 2 hots in it.
Oh.
So that's, we used to share a neutral with circuits, so we don't do that as much anymore. So you'll still see the white, number 12 wire, white, number 10 wire out there, but it's all the new stuff purchases colored, white, 14, 12, yellow, and 10 orange.
Can you tell me what in the heck is, what's the neutral do? I mean, can you tell us in layman's terms how that works? I mean, I can picture a hot wire, live, right? Electricity running through the copper wire.
It's the return back, so it comes hot and back in the neutral, right?
Okay, goes in the hot, comes back in there, so it's a circuit. You can interrupt that circuit with a circuit breaker. And circuit breakers are made to give you overload protection and heat protection too, right? The trip when it gets too hot or.
Arc fault breakers that require the arc fault GFI breakers, arc faults. Read the difference between the ground and the bare wire. Any difference between the ground and the neutral will trim the arc faults. Sorry, the GFI is the ground faults.
Right.
The arc faults are read the differential if there's any sort of sparking between cause that arc fault trip. So we get something a lot of, you get nuisance tripping, but it was really doing its job, it's just picking up an arc, and the arc was the light bulb tripping. But sometimes it's a lamp, you know, they like the old, in the bedrooms used to have 2-wire lamp, 2-wire cords, plugging lamp, those cords would get shorted. And trip. I think that's part of the arc fault.
So our arc fault, but I know GFIs are required anywhere within 4 foot of any kind of a water
No, we
precipitation.
used to 60, but now it's pretty much anywhere. Either it's a GFI or an arc fault, pretty much everywhere.
Everywhere.
I mean, except for some specific.
And those are outlets, duplex and quad outlets.
Yeah.
And that doesn't apply to switching, so.
Switching's on arc fault. Lights on arc fault. And in the beginning, arc faults seemed to like always trip on their lighting, but they don't seem to trip now. But it's really caused people, we have a job recently, we're working with some other electricians, we're doing some computerized stuff behind it, but we got there and none of the arc faults would hold well. And it's very common, neutrals get tied together between 2 different lighting circuits, and if they all lights go together, everyone thinks, oh, lights go together, put them all together. When they're together, the breakers recognize it, so the arc faults have really helped in finding problems that people would never even have diagnosed before. So it's
Yeah, and then once they're buried in the wall, they're pretty hard to fix. Now, what about the idea of a half hot? Because I know we've got a bunch of them in here, half switched outlets, right, for lamps, not completely switched, but like the top would be hot and the bottom would be switched, or vice
Right.
versa.
So
Is that pretty prevalent?
Used to be really prevalent, and we still use them a lot, but we don't use them as primary lighting. Here in some rooms, I think she uses it as a primary lighting. But what has to happen if you want to have it on a dimmer, you have to use a specific outlet that will allow the outlet to dim without burning up a vacuum or whatever. So if you use a standard outlet, anybody can plug into it. And if anybody plugs into the dimmer, they'll burn up whatever they're plugging into, ruin it.
So basically, if you wanted to put your lamps that were plugged into your half outlets, which were controlled by a switch, and you wanted to have that be on a dimmer, you have a few other hoops to jump through to make that happen.
We use a specific device for the outlet and a specific cord in on the lamp.
Wow.
And then the dimmer will do it. So then the lamp will plug into it, you can dim it up and down, but no one else can plug it. Vacuum.
Yeah, which would suck for your vacuum. I mean,
vacuums.
And that's not a good thing for a vacuum. You might think it would be, but it's not. Yeah, so, and you guys ran this, so that's another thing, yeah, I've seen a lot of jobs where, but I mean, this is a clean job. Some of the stuff that, this is when you watch an inspector walk around, they want to make sure your Romex is tight.
Yeah, not so tight that it damages the wire, but tight enough that it doesn't fall. You know what I mean?
And also tight enough if you happen to be icing in the walls, it doesn't
push out.
blow out.
Well, one of the things is, in the code and all of our rules and inspectors, it says, workmanship-like manner.
Mm-hmm.
Well, that's kind of up to the person, right? And it's up to the inspector to enforce, but I push my guys to make it better, always trying to do it better, and, they get tired of hearing me, it's not good enough, but that's super important to me. I know if they care about.
Are these adjustable boxes?
These ones are, some are.
Because it ain't 5/8.
That little tab right there is supposed to be that's actually the half-inch tab. So it's a little further than a half-inch tab. So 5/8 drywall, and that's another thing. I mean, you just brought the drywall issue. We use 5/8 drywall here. I mean, we've been working here for years. We use 5/8 drywall. 5/8 drywall. If you get out of an apartment, you get in and down there, it's like, really? We still use half-inch everywhere. I'm like,
Use half-inch anywhere.
yeah.
And it's not type X 5/8 is the 1 hour firewall, and half-inch isn't. So.
Yeah. So I don't know why that is, but I know a lot of counties or states are using it. Out of California for sure.
Yeah. I'm just super. I thought you guys were going to strap a whole bunch of stuff. I wasn't even thinking about how much.
We did it behind it.
Well, you have some hid behind there. You have a gas pipe behind there, and this Smurf tube which is taking data stuff, right?
So I think you ran the data stuff free, and then left the empty Smurf tube for future.
Okay, right.
Right.
So that tube, that orange tube, is a conduit that's available to pull new wire from one side of the house to the other, because this is all volume sealing. And once this is done, you're not going to be able to run that thing without it showing. But I'm just still amazed with as much stuff that was up there, But there's that many circuits.
Well, there's another thing. I mean, I don't know how everybody else does it, but it just seems like a lot of guys have extra circuits in their panel. And I'd love to have a lot of extra circuits in our panel, but when I run things, the amount of circuits we run, it seems like we often fill up a lot of the panel. But, you know, we don't get a bunch of overload tripping all the time.
No, and you
Plugging
don't.
the vacuum
You don't
contributor.
get it where people turn on their god dang microwave and.
Right, and I don't want to call my breaker trip. I said,
No.
hopefully if I wired your house, I'm not getting those calls. I
Yeah.
told someone before, not your number, I said, you have the office number, but hopefully you won't need my number. If we do it right, you won't need my number.
And no, I don't want to give it to you either. See, is it anything in here that I was so impressed with those runs. Those, what did you call them again? Those things with all the holes in them that they.
Home run helpers.
Those home run helpers. I can't really see them from here, but there's just a whole plethora of
They
them.
don't work everywhere, but we should try.
I think we had them up here as well. I saw a bunch of them. So you guys, in wiring this house complete, because there's no stone left unturned here. There are no old boxes. No old wiring, all new circuits, new outlets, new switches, new lighting, new fans, new everything. Because like I said, I'm gonna ask you something about it. What, were there anything particularly challenging about this house at all? Was it pretty standard? I mean, other than getting across.
It's just, you know, not being able to use this, which was attic space. That we
Right,
didn't
right.
So getting across here.
Which is a big deal because normally in a regular house with cyclone truss like this bottom cord, that bottom cord, that's what takes the ceiling drywall. And then this is all attic above, which you don't have to be all that clean about it. You can just run it forever. And nobody really cares because nobody's going to go up in that attic. Now here we have a fairly small attic space and it's not a whole lot of electrical up there. And then over in here, what did I see in here? God, I just. Look at that. I've never seen these before.
Those are called stackers. Those have been around a long time. Those are what they used to use before the other ones, and instead of staples, and they're pretty good. They do fall loose sometimes, so sometimes even though, but you won't see much of that. I mean, typically guys don't just die, but you know, like trying to please me, so that goes in kind of that.
Well, they're really, it's just clean. I mean, everything's really clean. And these guys are circuits for the
I told the
air
guys,
conditioning.
does it take any longer to drill a straight line than it does to drill a crooked line? I mean, it really doesn't if you just have a little bit of a plan.
Yeah, like these lasers, everybody's so fond of breaking out.
I grew up, we just stuck it on, you know, this is a different length in here, but we just stick it on our knee, and every one you put on your knee, every stud you're on right on your knee, and see spots in a straight line.
True, true. Rich, do you know what this box is for up there?
That's the smoke detector, which has to be.
Of course, it has to be a wired smoke detector, right?
Yeah, yeah.
Within how far of the peak?
Each manufacturer is different. Yeah, the last inspector asked us to bring the manufacturer specs because they've been different. But they used to be more than 12 feet down. Some of them are between 4 and 12 feet down. Some are different from the walls than the peak of a single ceiling, whether you're in the triangle or below. So it's really good to reference your manufacturer.
This is another thing I've seen you guys do a lot, which is get spare and empty Smurf tube / conduit for future data runs to places that were going to be virtually impossible to do cleanly without opening a wall. So now what you've got is you've got that tube would get data all the way from the panel, all the way from your kind of main control data box. It would get data, you'd be able to pull it to here, to this spot, all the way across after the house is completely done without opening anything up, which is a pretty dang good deal.
No one thinks they want anything when they're building a house.
Right.
Everything's on a budget, and they're just trying to be careful and later and then move their furniture and everywhere they do.
No, it's really great that you do anticipate that. Really, really great. I really appreciate it a lot. And just the job is so clean. So if you guys haven't been picking up your wire tailings, somebody has.
What's that?
If you guys haven't been picking up your wire tailings and insulation, somebody has.
We've been trying to be a lot better through the years, because you know, it used to be panels had crews on the job site now.
Right.
Now, all the kids go to college and they run the job sites from the paper and every sub is responsible for themselves kind of, and it's a little different.
Yeah.
It's changed. a little bit.
It's a little different. Well, Rich, it's been a pleasure interviewing you. Rich is my electrician. He's the only guy I ever want to use. And it's because he does things right, usually the first time. And if he doesn't, he's willing to come back. And he's really helpful. And he's got a good personality. So, Rich, say goodbye to City College. Thank you so much. Rich Saga, what did that say? Said, he's the only guy I ever want first time, and if he doesn't, he's willing to come back. And he's really helpful, and he's got a good personality. So, Rich, say goodbye to City College. Rich Saga Body. Anyway, it doesn't matter. So, okay, comments, questions, please.
Rodney, in the master there, where the orange Smurf tube ran to,
Yes.
it looks like there's still a low voltage box missing there.
Yeah, they haven't put the box in.
No.
Now, they may not put the box in. As a matter of fact, I suspect that area and another area or two, there won't be boxes. They'll just, in that, because I'll make up a house book, with all the, appliances will be in it, and just all the information, plumbing fixtures, appliances, and everything I can put together for the house. And then one of them will be pictures and dimensioned of various rooms that have stuff in the walls like that. So they'll know where that Smurf tube is in the wall, so they can do a cut-in box. So what you're mostly seeing there, those blue boxes, those are boxes that hold the wires that get the switches or outlets, and they get drywalled around. Now you can put a cut-in box in virtually any wall where you just cut out for the box. You slip the box in, and then the box has little arms that slide over, and then you crank the screws, and the arms come up against the back of the drywall and holds the box in. So you can cut in boxes, and that's what they would do in a situation like that.
Rodney?
Yes.
Hi, it's the captioner. I'm sorry, but I had a power outage in my apartment.
Okay.
And could you please assign me to caption again?
Oh,
Because
sure.
I lost that connection. Thank you so much. Sorry for the inconvenience.
Yeah, I know. Sweat. Let's see. Okay. Closed captioning. Find a participant. Captioner. More.
She's being nice.
Type caption. Okay, Linda, you should be live.
Yes, I got it. Thank you so much again.
Oh.
Sorry.
No sweat. Now,
Much better.
we're running out of time. I'm going to show you. Well, I'm going to start showing you something that I'm going to probably say goodbye in the next 7 minutes or so, so I can go hit that white ball into the wind, which is not my favorite thing to do. If you guys can all get together and make this wind stop, that'd be really great. Be extra credit for that. Okay,
Yeah, we're
so
supposed to get 70-mile-per-hour wind gusts over here
where?
in Hesperia.
Oh my God. Wow,
Yeah.
There.
Yeah, I'm not looking forward to it.
Yeah, well, they're saying 40 for us, which is bad enough.
Yeah, we get that one a lot.
Okay, so can you all see this?
I let in.
Can you all see the board?
It's a little small.
Is that better?
Yeah. Yes.
What I'm illustrating is, I was going to show you how to lay out a staircase, but I'm not going to have time to do it. So I'm just going to start out by saying that in a typical stair, if you're doing typical stringers, this would be a stringer. Rise, run, 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 rise, run. I didn't, this isn't a scale, so you don't usually have those two steps like that at the end, but This would be a stringer cut out of a 2x12 or a 2x14, depending upon what you were cutting. Typically, we use 2x12s for stringers, and that's what I've got for you for the stair stringer to lay out and cut stairs. And I think I'll do that next week, first of next week. But basically, any staircase anywhere, and let's for at this point discount landings, staircases that need landings, or turning staircases. We can talk about those at another time. Just a straight run staircase, you start out with two numbers. One is total rise, the second is total run. In this case, our total rise is 108 1/4, and it's from the floor, we're going to say subfloor, 96 inches of wall height to the bottom of the ceiling joist, which is 11.5 inches, and then 3/4 rough sheeting for a plywood subfloor. Okay.
John, because he seems to know a lot about computers because he has lots of them. He has
So
the one
this
he's on, one next to him. He has one next to him, I'm thinking.
Okay.
He has two behind him. It could just be like us. Look how many computers we have in this house.
Sorry, someone's not on mute and it's very difficult to hear.
It is. Somebody please.
Sorry, it's me.
Thank you. Okay, so total rise, 108 1/4. Total run, and in this case, we're not limited with our total run. This is one of those conditions, say this is a mezzanine in your really high ceiling garage, or you're getting up to the second floor, and you don't have a limiter on your total run. I've made total run 140 inches because I worked backwards, figured out the risers using around 7.5. There are a lot of components to staircases and figuring and cutting stairs, but one of the things you want to remember is your ideal rise, unit rise and unit run. So from total rise and total run, you're going to get unit rise and unit run, which is going to be each individual stair. From there, you're going to get, those two will add up to a number, and that number should add up to somewhere around 17.5. 17.5, 17 5/8. That's the ideal. So really between 17.5 and 18 is combined unit run, unit rise ideal, which means we started with 7.5, and as it turned out, going into 108 1/4 equally, 15 times, we get 7 3/16 plus rises. Those are good and acceptable rises. So we're going to add to them a 10-inch run. Now I could make that a 10 1/4 run and get closer to 17.5, but I did a 10-inch run because I want to use a 2x12 for my stringers with an 1.5 inch overhang past this rise. So I'm using a 10-inch run. So I know that in figuring the rises, I did my 7, as it turned out, equally, 7 3/16. It's actually 7.216. 7 3/16 would be 7.1875. So that's why it's 7 3/16 plus. You can't see that, can you? So it's slightly less than 1/4 and more than 3/16. There's always one less tread than risers. So because I know my total rise and I know my unit rise, I get unit rise. I didn't write unit rise yet, but my unit rise is 7 3/16 plus. I know that I got 14 treads. 15 risers means 14 treads. And if my treads are going to be 10 and my rough treads are going to be 10, 14 times 10 is 140. And that's how I got my total run. So between total rise and total run, I get my unit rise, which equals 7 3/16 plus, and that's would be that dimension there, and they'd all be the same. By the way, they have to be by code all the same. You only get 3/8 of an inch difference. So they can be off by 3/8 of an inch, and that's the maximum. They should be all exactly the same, and that's so you don't trip as you're coming up and down stairs, because your feet anticipate that riser, that same riser. It doesn't anticipate any difference. 3/8 is all the slop you get. And you also got to figure finished floor, top and bottom. In this case, we could figure the finished floors would cancel themselves out, because I'm going to put 1 inch of pad and carpet down here and 1 inch of pad and carpet there. So they cancel themselves out. So finished floor is also a consideration when we're starting to step these off. But right now we got a unit rise of 7 3/16 and a unit run of 10 inches. And that's 10 inches from there to there. And that gets us to the place where we're out of time. And next week, I'm sure I'll get to it. I'll show you how to take and put that unit rise 7 1/4, or actually 7 3/16 plus, and 10, and step it off on 2x12 stringers and make the layout for your stair stringers. And once one is cut, it makes use it as a template. Use it as a template for the other one or two. Okay, so I don't really have. Well, I do have got a minute or two for questions. Anybody have any questions off the top of your heads? Okay, I'm going to leave it at that, and then I'm going to just one time. If Dario, did you make it?
Hey, Rodney, I don't got a question, but I got a comment.
Dario, did you make it? Donna, did you make it? Michael Silva, did you make it? And Dennis Vega? Okay, so you guys are all unexcused in your absences. Remember, if you're not going to make it and show your face here, text me, call me, or email me and tell me why, and you will more than likely be excused unless it's just some really completely out. If you call me and give me an excuse, I'll buy it.
Hey, Rodney.
Yes.
I don't got a question, but I got a comment.
Fire away, please.
Your buddy looks like Cal Ripken Jr. Remember how you said he was a baseball player?
He looked like a baseball player.
You said he looked like a baseball player?
Yeah, what about him?
Pull up a picture of Cal Ripken Jr. Looks just like him.
I know.
Rich boy.
Yeah. Because when you said that, I was all like, yeah, he does look like a baseball player. And I was trying to figure it out. And then when he turned sideways, I go, he looks like Cal Ripken Jr.
He does. He looks like Cal Ripken Jr. That's exactly right. I've got to go. I've got to be somewhere. So it's a pleasure. Always. See you all next Saturday. In the meantime, please stay healthy. Get vaccinated if you can. If you want to. I hope you do. And I'll see you.
All right, Rodney. Have fun.
John, I'll your stuff will be in my car. You don't.
Yeah.
You don't want me to leave it at the shop, right? You want me to take it home?
Do you want to? I'll text you my address. You can drop it off on the way home from golf.
Yeah, do that. Okay.
Okay.
Goodbye, everybody.
Yeah.
Take care.
You too. Bye, Catherine. Good to see you, Kat.
Rodney, would you be able to stay for just 1 or 2 minutes?
Yeah, I got about 2 minutes.
Okay, great. I just wanted to let you know that the videos are, you can't hear anything on them. I don't think anyone can hear it. You can hear your voice only, but no one that you're talking to, you can't hear them because there's so much banging. And I think just the way that the camera is, it's just impossible to hear. So Katie and I are unable to interpret during those videos. I didn't know if there was anything else we could figure out, if there was a time that you could go, like maybe after work hours or something like that, because we can't interpret it.
What about the closed caption?
Well, we interpret into sign language, so the captions are there, but Hugo's first language is American Sign Language. So that is the access we're trying to provide, but we're unable to do that because of the sound quality.
Okay.
What we're noticing is that it seems like maybe it's a function of the phone, but it picks up your voice pretty clearly. But then the person who is opposite you sounds like they're really far away. So sometimes it's just a mumble. And in terms of the access with the captioning, that certainly is helpful. At this point, we're just letting him rely on that. But because he's reading in a second language, he's behind in the reading. So sometimes just that processing time is a much more challenging as the opportunity to see it in sign language or maybe look at the English after the fact.
Okay. So I don't know quite what to do about that, but I could try miking up whoever I'm interviewing.
That might help.
Yeah, that might help.
Yeah, but then you won't be able to hear me. So we'll try that. We'll try that, or maybe I'll mic me up and then pass the mic over.
There you go.
I'll
That
see.
might do it too.
Yeah, I'll see what
Because
I can
I think it's like your phone just wants to favor you because you're so close by, and maybe it's
It's
calibrating.
not my phone. It's an HD Canon video camera.
Yeah.
It's not my phone. It's a video.
Okay, but whatever it is, it's picking up you, but then the other person, it sounds quite muffly in the distance.
Yeah, well, thanks for that. And I haven't gotten that feedback from anybody else but you guys. So let me just make sure that it's across the board. I imagine it is if it's both of you getting that. And then I'll try to do the wireless mic.
Sounds good.
Next time I interview.
Sure.
Okay, and we'll see if that does it.
Okay, sounds good. I mean, if you could just, even if the other students can hear it, which I suspect they can't, it's still critical that Katie and I can, because we have to be able to interpret. So if you could please do the mic anyway, it would be appreciated.
Yeah, I'll do it anyway. I'll give it a try and we'll see if that doesn't work. I'm not sure where I'm gonna go with it, but
We could definitely brainstorm with Christian or something like that if that doesn't work.
okay, it's a deal.
Okay, thank you.
Thanks.
Bye.
Bye.